So this video is to go through how to solve a mathematical word problem, which you'll do a lot this year. So I've broken it down into steps for you. The first step is to identify the information given to you and pair it to a symbol that it represents. Because in science, all of the numbers you're given also have a symbol for whatever concept that is. Pressure, temperature, time, velocity, whatever. The second step is to convert whatever you're given to the proper units and choose an equation. After you have an equation, you can plug your information into the equation in the proper places, and then following math rules, you can solve to get the unknown alone on one side of your equation. This is your answer, and all you have to do is make sure that you have units and circle your answer. So let's see how to apply all of this information to an actual word problem. So our problem is a 600 milliliter sample of nitrogen is heated from 27 degrees Celsius to 77 degrees Celsius at constant pressure. What is the final volume? So step number 1 tells us identify the information given and pair it to a symbol that it represents. So I see 3 different pieces of information here. I see 600 milliliters as one piece of information, 27 degrees Celsius as another piece of information, and 77 degrees Celsius as a third piece of information. So I'm going to write that down. I have 600 milliliters. I have 27 degrees Celsius, and I have 77 degrees Celsius. Now I need to connect this or pair it to a symbol that it represents so that I know what the concepts are here. So milliliters is a unit of something that we call volume. And I know that my symbol for volume is V. So I'm going to represent that V. Degrees Celsius is the unit for something that we call temperature. And that is a capital T. So the last piece is we have this little piece of the problem we have not addressed yet. What is the final volume? That's what it's trying to get us to solve for. So we're looking for a V here. And because we have a change going on from an initial sample to that sample being changed in some way, we need some subscripts here. So the 600 milliliters represents V1, which means V before the change. 27 degrees Celsius is T1, which is temperature before the change. 77 degrees Celsius is T2, which is after the change. And we're trying to find the final volume, which means we're solving for V2. So now if we go back over to our list of steps, number 1 is done. We have identified the given information and paired it to our symbols here. Step number 2 is to convert to proper units and choose an equation. So we need to convert these to our proper units. We do not deal in milliliters, we deal in liters. And the way that we would convert milliliters to liters are this: there are 1,000 milliliters in every liter, so we need to multiply this by 1/1000th. So 1/1000th times 600 is equal to 0.6 liters. So that's the information that we're going to use. I'm going to get rid of this conversion just to save some space. And I'll move our new converted piece of information into its proper place right here, 0.6 liters. The next conversion we need to do is with our temperature. In these problems, we need to use the units of Kelvin for our temperature. And in order to get from degrees Celsius into Kelvin, we need to add 273. So 27 plus 273. Same thing down here, 77 plus 273. So 27 plus 273. Let's see if I can put that in my calculator. 273 plus 27 is 300 Kelvin. And then 273 plus 77 is 350 Kelvin. So now, to simplify again, I can erase all of this stuff, and I'm going to bring my new converted temperatures with the proper units over into their proper spaces over here. So we have converted to proper units, but now we need to choose an equation. So if you look at this information, we have some V's and we have some T's. We don't have anything else. So when you look at your equation chart, you should try and find an equation that has V's and T's and nothing else. And we actually have an exact equation for that, and that is Charles's law. And Charles's law has the form V1 over T1 equals V2 over T2. So step number 2 is done. We have converted to the proper units and chose an equation, Charles's law. Step 3 is to plug our information into the equation into the proper places. So V1 is what goes here, and V1 in this case is 0.6 liters. That's divided by T1, which in this case is 300 Kelvin. That's what we converted it to. That's equal to V2, which is our unknown, so we leave it as V2. And then T2, which is 350 Kelvin, goes on the bottom. Step number 3 is done. Now, we have identified the information, we have symbols, we have proper units and chosen equation, we plugged in our information, and now we need to, following some math rules, solve to get the unknown alone on one side of the equation. So our unknown here is V2. It's that guy right there. So we need to get him all by himself over there. To do that, the first thing I'm going to do is I'm going to do everything on this side of the equation. So that's 0.6 divided by 300. If I put that into my calculator, 0.6 divided by 300, I get the number, let's use black here, I get the number 0.002, and that's equal to V2 over 350. Okay, to get V2 by itself over here, the next step is to multiply by 350. So I multiply 350 on both sides, and what that does is that makes it cancel over here, and all we're left with is V2, which is exactly what we wanted. So now we have V2, which is equal to 0.002 times 350, and when I do that in my calculator, I get an answer of 0.7. So we have V2 all by itself over here, so step number 4 is done. Now, the last step, step number 5, is just wrapping everything up, and that's to add units and circle your answer. So if we look at this problem, V is what we were solving for, and we need our proper units for volume. If you look up here at what you were given in the problem, our volume is given as in liters, so that means our answer will also be in liters. So I'm going to come back down here, I'll put an L for liters, circle my answer, and we are done. This is an example of how to follow these steps and solve any kind of mathematical word problem you could be given. We did a gas law problem here, but this could fit to any kind of mathematical equation or word problem that you might be given in science class or in math class.